And here we are. Hello, everyone. Welcome to the live stream. I'm here with my colleague, my favorite colleague, actually, Oleon. Welcome, Oleon. How are you today?
I'm fine, you?
Yep. I'm doing good. Always good to be on a live stream. So, very, very happy to be here. We've got an exciting one today. Now, these are my favorite ones when I don't have to do anything too difficult, which is why I bring in my colleagues. But we're going to be looking at ggshield. We're going to be looking at how we can detect secrets using this tool. It is a CLI tool. We're going to get a little bit further into that as we go. But we're going to be talking about not only detecting secrets in your Git repositories, we're going to be talking about detecting secrets before they get there, detecting secrets in other areas like Docker images, detecting secrets in files, directories. And so we can kind of really be able to expand on our capabilities using this tool. So let's get started. Now, we're going to be doing kind of hands-on demonstrations with Oleon. We have a couple of slides to get through at the start, just because I want to keep everyone up to speed. But we'll get through those hopefully relatively quickly because, live demos are much more exciting. So just what we're going to go through today is we're going to look quickly at the State of Secrets Sprawl report, because just to refresh everyone's mind about why secrets are important. People are probably sick of hearing this if you've been to webinars before. We're going to be talking about where secrets detection is, why developers should worry about secrets detection. We're going to be looking at ggshield. We're going to look at how to use ggshield, and then we're going to be doing some demos, and we're going to be doing some Q&As. So Oleon is one of the main contributors to ggshield. So if you have any questions, actually now is the time to ask the expert directly. Now, as always, there are prizes available in these webinars. We've got some Amazon gift cards today to give away. So participate in the chat, ask lots of questions, participate in the polls, and you'll be able to do that. Now, if this is your first time on Crowdcast, or if you're tuning in on YouTube or Twitch or some other stream, Crowdcast is the main platform. Down the bottom, you'll see some buttons. You can ask a question. That's the best way to ask us a question, because the chat can get pretty noisy. There are some polls there, so you can participate in the polls when they come up. And feel free to participate in the chat as well. So just while we're waiting for the few extra people to come here to jump on, let us know whereabouts you're tuning in from. So I'm in Paris today, which is good. Oleon, I believe you're in Paris too, unless you've taken a sneaky vacation.
Well, I'm in like 70 kilometers east of Paris, but I guess that counts as Paris.
You live out in the countryside, a man of luxury. You have a backyard. Yeah. You have space. Something the rest of us don't have. All right, we'll see where some other people are tuning in. We've got here from Milan. I was in Milan not so long ago. Montreal. We've got I saw someone tuning in. Edmonton, Paris, Lagos, Mexico, USA, Cologne, Bangalore, London-ish. That's kind of like your Paris-ish.
Yeah, I can relate to that.
Tel Aviv, Spain, Chile, Munich, Princeton, Cologne again. A couple of people from Cologne, Germany, Poland. Christoph, is that? I think I might know. I know a different Christoph from Poland. Might be the same person. Might not be. But anyway, it's great to see everyone. New York. It's great to see everyone tuning in from all over the world. It's my favorite part of the webinar. I do this every time. People probably get sick of it, but I quite enjoy it. All right, so we're going to get stuck in. We're going to move on quickly now. So we're going to take a little bit of a throwback to the State of Secrets Sprawl. This is a report that GitGuardian does. We talk about secrets. Now, if you're not sure what a secret is, we're generally talking about digital authentication credentials, API keys, credential pairs, security certificates, anything that gives access to external services or systems. Now, we monitor public activity for these secrets. We found 6 million sensitive keys in github.com last year. 6 million. So that's just in public GitHub. So that's API keys that have been publicly exposed in github.com. So this is a huge problem. Why do they get exposed? Because they end up inside our source code and we push that. Now, attackers are also targeting private code repositories because these are a huge kind of bed of secrets. And one of the reasons for this is that we have to remember that when we're coding, our version control systems keep track of everything. So when we commit something, if we commit a secret, a year later, that secret's still there. Unless it may be deactivated, hopefully it is, but it's still in that history. So they're really hard. They can be not visible. So we have to be careful about this. Now, we find all kinds of secrets. So data storage, access to databases, 21% of that 6 million last year was databases, up from 15% the year before. Cloud providers, so access to Amazon, AWS servers, GCP servers, very easy to use these maliciously. Even if it's a personal account, you can rack up some pretty hefty bills by doing some crypto mining on these, and a whole bunch of other things. Private keys, development tools, messaging systems, version control access keys. So lots of different things. So we don't want these secrets inside our Git repositories. We don't want these secrets in our source code. So we need to become alerted if they do. We need to scan our Git repositories, but better yet, if they don't even make it to our Git repositories. That's what we're going to be talking about today with ggshield. So one of the problems with secrets is that it's very linked to developers. So we as developers need to be very careful of how we handle these sensitive information. So we have access to API keys. We need them to access to test our applications, to build our applications. We have access to databases. So because we have access to the sensitive information, we need to be really careful about where it ends up. So just a poll here, the first poll. So down the bottom, you'll see that answer for polls. Who here uses secret scanning in their CLI in development? So this isn't including if you have GitGuardian on your repository. I'm looking about who's doing secret scanning in other areas using their command line interface, or maybe some other tools, maybe in your CI/CD pipeline. Now, do you currently use ggshield? Do you use any different secrets detection tools? I won't be mad. I promise I won't be mad. You can answer honestly. So Trufflehog or GitLeaks. And do you have secret scanning on your repository but not anywhere else, or do you just not scan for secrets at the moment? Let me know in the polls. I'll have a quick look now at where we're heading up. So actually, we're tied at the opposite ends for the moment. So 10 people are using ggshield, 11 people not scanning for secrets at all. So we can help. We can help with that. Hopefully by the end of this webinar, we'll all be scanning for secrets. We just jumped up. 12 people don't scan for secrets in the CLI, but do use GitGuardian. So that's good to see that we have some secrets detection in there. See a couple for GitLeaks. There are some good tools, open source tools out there like GitLeaks. But we're gonna be focusing on ggshield, which is, in my unbiased opinion, the best. What do you reckon, Orleon? In your unbiased opinion, ggshield is it's the way to go?
As unbiased as yours.
Yeah. Okay. So let's have a look at what we're talking about when we're saying detecting secrets in our CLI. So on the screen, you'll see two kind of categories here. We've got our local environment and our remote environment. So our remote environment is kind of, if you think about it, that's our remote repositories, our Git repositories. When a secret enters our remote repositories, that secret's compromised. We need to be looking at revoking that secret. Even if it's a private repository, that could end up on multiple different developers' machines. It could be backed up areas. We've lost control over where that secret is, but that's critical. That's where we need to know where the threats are. On our local environment, it's a bit different. If we can detect secrets on our local environment, so for instance, when we create a commit or when we push a commit, or after we've pushed it, but before it reaches our remote environment, that's different because that secret hasn't been compromised yet. We don't need to rotate that secret because it hasn't been exposed anywhere. We can simply remove that. Maybe we need to change our Git history a little bit there, but we can move forward. Remediation is so much simpler. So that's what we're going to be focusing on. How can we detect secrets before they get to our remote repositories? Now, if you're not familiar with GitGuardian, GitGuardian is a tool. We've got a SaaS platform. We're free for small teams, and we detect secrets on that remote repository. We integrate with your GitLab. But once we detect them, they're already compromised. ggshield, which is our open source kind of version of that, is about detecting them before we get them and detecting them in other places. So, Leon, why don't you give a very brief introduction? What is ggshield? How does it work?
Okay, so ggshield, as you said, is a CLI tool to scan your repositories, and it has lots of different scanning modes. You can scan files, you can scan Docker images, you can scan PyPy packages, you can scan your commits, and more importantly, you can integrate ggshield inside your Git workflow, your local Git workflow, so that you catch secrets before they leave your machine.
Right. So with ggshield, we're not so focused on just Git repositories. We can literally take that detection engine from GitGuardian and we can integrate it elsewhere. So we can scan a file, we can scan a directory, we can scan a Docker image. So we're basically making a more mobile version of that detection that we have at GitGuardian. Would that be a fair statement?
Yes.
Right. It's almost like I had that prepared. So ggshield is open source. It's on GitHub, so you can contribute to it. You can see the source code for it. We use the GitGuardian API to actually scan the secrets. So the one disadvantage to ggshield is it does need to be online because the GitGuardian API still needs to ingest that data and it will return a result. But ggshield is really powerful in the sense that it is a wrapper that allows you to do lots of different tasks using that API. So we're celebrating our 2nd year anniversary. I think we just crossed 1,000 stars on GitHub. So congratulations. Congratulations, everyone, Olion, for that big milestone. If you're feeling so kind, you can find ggshield on GitHub and give it a star. The marketing team will love you for that. GitHub stars are a bit like currency sometimes. And of course, we're open to contributions. So if you have a specific use case for being able to detect secrets somewhere in a specific environment, in a specific infrastructure, the chances are someone else is going to have that need as well. So we'd love to hear from you and would absolutely love contributions. So please feel free to kind of be part of the ggshield team. We do give out cool swag to the contributors and people that are active in the community there. All right, so where and how do we use ggshield in the CLI for developers? So this is a similar slide to what I had before. So when we're talking about integrating into our development workflow, what we're really talking about too is being able to detect secrets in a couple of key areas. We can use it as a pre-commit hook. So this is when we make our commit, it's going to check it. It's going to scan that commit for secrets. If it finds one, it will alert us and it will block that commit. So that commit won't be added into our local, our local staged environment. We can remove that key. We can redo the commit and we can move forward. We can detect secrets in a pre-push way, which is basically scanning a group of commits, but it will block that push if it contains a secret, just as it did before. And we can actually use a pre-receive hook. So this is where it's going to block it from entering into our server, but it's after we've pushed it. So we'll talk about a few of those and some other functionality as well in our demo, and we're going to show you how to set up ggshield and how to move forward from there. So one of the big questions that we have, the battle of the hooks. Should we go for a pre-commit or a pre-push hook? So Oleon, what team are you on? Pre-commit or pre-push?
So
and why?
I'm mostly on a pre-commit because it avoids it makes rewriting history simpler, because you catch the error just as you made it. You don't have to go back. And with the downside that you need the internet connection to scan your commits, so it's not really appropriate if you're offline.
Okay, I'm not on team pre-commit. I'm on team pre-push. I'll explain why. So as you said, when we're on team pre-commit, it has to scan every single commit. But when a pre-push, it scans that group, so it reduces the amount of scanning that you have to do. And because we need to be online to push, we're guaranteed to be online so that it's going to work fine. There is a key disadvantage, though, for a pre-push. That's that if there is a secret there, I have to rewrite my history. Because it's already in my local history of my Git repository, I have to go back, rebase, change my history. So a little bit of a pain, but if you're not committing secrets that often, don't have to do it that often. So, I feel like if you get that far, you deserve a little bit of punishment. That's just me.
You're a bit a naughty developer.
So what about the pre-receive hook? Can you explain a little bit what the pre-receive hook does? So I understand pre-commit, pre-push. They're fairly self-explanatory. What's pre-receive?
So pre-receive is working on the server side. That is, when you push, the code leaves your machine and goes to the repository on the server side. And the pre-receive is on the side of the server, so it can stop things before it gets to the remote repository. But it's only possible to set up this on certain configurations. You need to own your own Git server, basically. So it's a bit more complicated than...
Right, so if you're using the free version of GitHub, for example, difficult or impossible to set up a pre-receive hook because you can't adjust that server configuration.
Yes.
Got it. Okay. But if you are running GitHub Enterprise or some other on-prem versions of GitLab, you can set that up, which is very helpful because it basically can enforce some stops of secrets actually getting committed. And also some other areas too, if you're using CI tools, so Circle CI, GitHub Actions, Jenkins, we can put ggshield into these as well. So we can actually add ggshield into these setups. Why are we looking to kind of add ggshield into the CI environments, Oleon? Why is that an advantage?
Well, not all commits are created by developers on the machines. So nowadays, CIs are getting smarter and smarter, and they do more and more things. So you want to ensure that they do not accidentally commit secrets themselves. So it's important to do that here. And CI also, well, if you do not have access to the pre-receive hooks, then you can use the CI to act as a pre-receive. That's what we do with the GitHub Actions, for example. So if you block your commits to the main branch and require that people open pull requests to commits on your GitHub repository, for example, you can set up a ggshield as a GitHub action, and it won't accept the commits if it contains a secret. But at this time, the secret is already online, so you would need to revoke it and do more remediation than if you copied it earlier.
Right. So it can prevent the sprawl of that secret, but that secret's still compromised in that scenario you just outlined.
yeah, at least the code won't reach production, hopefully, but
Got it.
yeah, you have more work to do.
All right. So good news, everyone. We are now at the end of the PowerPoint. So we can switch on to some demos. So if you want to follow along with these demos, what are some of the prerequisites that people should have installed? Getting started here. I think we need Python installed. Is that correct?
Yes, Python and the Git command line tool, which you most likely already have. And
Right.
I think that's about it.
Okay, Python, Git command line. If you have those things set up, then you're ready to go. The other prerequisites that we need we'll add to. So, Oleon, I'm going to add your stream, your shared, your screen share. There we are. I'm finding my English words to the screen now. I'm going to leave it in your capable hands, and I'm going to be monitoring the chat too now. And the questions. So if you have questions as we're going, I'll try my best to see them and interrupt Oleon and ask the questions.
Okay, so let's start by installing ggshield. As I said, ggshield is a Python application, so you can install it with pip installed ggshield. And if you prefer this, we also offer alternative systems. We actually have RPM or dev packages nowadays, and it's also available via Homebrew, as you can see here on the installation side. Anyway, we just installed ggshield. Let's check it works. Yes, we have ggshield version.
If you are getting an error with this too, you might want to try pip3 install, because I get that error when I use pip install. So if you're getting an error with pip install, you can do pip3. Just a quick a quick note.
Okay, so let's go in one of my demo. So here we are on the very simple source tree, and if you look at the config.py, you can see that it has something which looks hopefully like an AWS key.
So this is inside. This is inside that configuration py file that you have there.
Yes, that's the content of the config.py.
Got it.
So, well, if I try, ggshield has lots of ways to scan things. The simpler one is puff, but if I do this, it's not going to work because it's going to say, hey, I don't know you. So before we had to do some dance with tokens and things like that, but we recently made this a lot simpler. So we can do a ggshield of login.
So what you're doing now is generating an API key for GitGuardian. So to be able to communicate with the GitGuardian API, that's correct?
Yes. So as you can see, it opened the GitGuardian website, and since I was already logged in, it generated the token for me. And when you go back to the site, we can see success. You are now authenticated. It created a token with this name. So now I can try my command again. And boom, it found that secret. Huh. So we know we can address this. Now we can also scan world directories. If I add -r for recursive, it's telling me that it's going to scan 3 files. And surprise, there is another secret. This developer is really careless. If I look at this ci.yaml, whether it's an hypothetical format for a CI system, and we can see that there is a cover rules token secret here, which was cooked here, and both are invalid.
So what we're doing now is scanning through directories. We're scanning through the file systems on your computer to try and find secrets. What's a good use case for needing this? And And is this the same as if you're scanning a Git repository? Is what you're doing now the same as scanning that Git repository?
Well, this scans the tip of the repository, as in it scans the repository in its current state, but it doesn't scan the history. So you might be missing some secrets here. And let's move on to another example. Here we have, this is a Rust example. To change a bit. So I'm going to do the same thing. So scan all the repository, and it's telling me that it's going to scan 14 files. And whoa, no secret has been found. That must be good. But if we use the scan repo command instead, it's going to scan all the commits. So if there was a secret committed and badly removed, then it's going to find it. As you can see, it got my secret. And let's have a look more precisely. So here I'm going to open the history of my command. And we can see that he found 2 commits, interestingly, with the secret. So what happened here is that this is the first commit. And here in this commit, I added crates.io key.
Mm-hmm.
And then I say, oh, that was a mistake. So in the second commit, I removed it and replaced it with something which I guess we'll get from the server. But ggshield noticed that the 2 patches still contain the secret. So this is bad. And I will need to remediate this. Luckily here, the remediation is very simple. We can do it. If I just squash those 2 commits, then I will have something cleaner. So let's just do this, and I'm going to look at the log and say, okay, git rebase-i on this, and I'm going to squash those 2 commits. Hey, these are my CI configuration. So now, if I look at my history again, there's only 1 commit, and it only contains that I referred to crates IO defined somewhere else. So if I scan again, with scan repo, it's going to be happy, and it's spawning it. Yeah.
So I just want to make a quick clarification on what you did there, because I think it's really important what you showed. And that is that when you scanned the directory, you scanned the top layer of that Git repository, it didn't find any secrets because, as you showed, the developer removed them, or basically committed over them. So they weren't visible on that top layer. But then you changed the command from, instead of scanning the directory, to scanning the repository, which scanned the history.
Okay, so right. Okay, so let's move on. Now we are going to look at pre-commits. And so if we look at the README or ggshield, we can find that somewhere it's pre-commit. Sorry. Okay. Here we are. So pre-commits are little scripts that are run at, Git hooks are little scripts that are run at key moments in your development workflow. And one, which is very important, is the pre-commit hook, which is run right before you commit. You can create pre-commit hooks yourself, but it's often simpler to use the pre-commit framework, which we're going to install now. So we'll start by going to my next repository and install pre-commit.
So pre-commit is a separate framework that we're installing that's basically going to help us handle creating pre-commit, pre-push hooks and other areas. That's right?
Yes. So now I'm going to follow the steps and create a pre-commit.yaml file here and copy the content of this file. So now in this repository, let's look at what we have. We have a basic README and .precommit-config.yaml. And now that it's done, so we can, pre-commit install is going to look at this .precommit config and set up things for us. So we can say that it created a file named precommit in the .git/hooks repository. This is where all the hooks are. And let's try to add a secret. So I'm going to create my config.py, and I'm going to copy the same secret we saw before. Beautiful. And here we see that precommit is installing our precommit hook. This only happens the first time you set up the precommit. Next time it's going to be much faster. And of course, my network has decided that it's slow. Oh, and we can see that precommit, the ggshield precommit failed because it found our secret. So it blocked the commit. And if we look at the status, we can see that it's still added. In the added state, it has not been committed. And so
we don't have to rewrite our Git history at this point now, do we? Because that commit hasn't been staged.
Right. That's it. So we are saved. Now let's say that you're team pre-push.
Team pre-push, yes.
Okay. So for team pre-push, you need a slightly different configuration here. We're going to add push here, and we actually need push here as well.
This is the YAML file. This is the pre-commit YAML config YAML file, right? That you're editing.
Right. That's it. Yes. Okay. And then I'm going to uninstall. So you remember that the pre-commit created a pre-commit file here. And I'm going to uninstall this one. You can see it does not exist anymore. And I'm going to now tell it, hey, install my pre-push.
Right, so we've deleted our pre-commit and we've installed the better hook, the pre-push hook.
Yes. And now we can try committing again. Commit. Oh, bad secret. And it's happy. But
so the commit's gone through.
Yes, and if I look here, it's okay. Well, my coffee file is not commit, but it's not wrong. But if I get push, then I'm getting caught by the pre-push police. My commit didn't make it to the remote repository.
Great. That's really cool.
We are still safe. Okay. So what else can we show? We can also show the GitHub action.
Yep. We have a question here that's coming up. People are wanting to know. It's coming back. You know what is the tool that you are using to view the commits?
Oh, it's called TIG.
TIG. Okay. That was one of the ones
in regress.
Yeah,
yes,
cool.
It's really nice. You can do a lot of things. I use a very small amount of it.
Yeah.
You can actually create your commits with it.
Yeah. There are some people in the comments too that are on your side with the pre-commit hook. So it's all right. It's all right. I won't blame them.
Okay. Okay, so let's move on to the GitHub action. And for this, we're going to make a few changes on the server side first. As I said earlier, GitHub Action is only really interesting if you have protected your branches so that you have to open pull requests to make your code go in. So I'm going to do this now, and I'm going to move to my demo repository.
So we're using GitHub Actions, but is this similar to other CI environments? So would this be similar process to say Circle CI or other or Bitbucket pipelines? It's similar in terms of concept, yeah.
Yes, basically you want to prevent things reaching your main branch and have everything go through an approval so that the ggshield has a chance to get in between. So I'm going to go to the branches here and add a rule, and I want my last branch to require a pull request and create a home. Password. Okay, so my master branch is protected. Let's see. Here I made a commit to my master branch. I'm going to remove, not the right one, sorry, to uninstall the pre-push pre-commit, the pre-push hook, sorry. And now my push should go through. Well, except I failed something. Haha. Demo effect. Why did it? It shouldn't have accepted my commit.
This is why I live demos. So never worry.
I save change. Wow. Maybe I was not on the right thing. Oh, that was correct. Interesting. So I have a secret here. That's bad. Okay, let's revert it for real. I'm just going to delete the one. So we are back in the first commit. This is a good reason to push force things. Now now it doesn't want me to push force anymore. Okay, now so I guess I was too fast, and now it's protected. Okay, let's remove the protection. That's an interesting demo. Edit. Or maybe actually, let's see. No, I need to delete the one thing. Yes, here we go. Okay. So, let's try this again.
So you're just a bit quick there. I think GitHub would quite process your requests.
Yeah, maybe. And maybe that was also why I could. Because by default, the administrator can bypass some rules.
Right. Okay. And as you're the administrator, this is a good example of, even though when people think they have protection set up, how they can still fail. And this is in this case, and you're not allowed.
So
accidentally leaked a secret. So.
Yes, that's a good example of a secret accidentally going live in front of lots of people. Anyway, okay, let's try again. And hopefully, I'm going to put like my secret. Commit secret, and hopefully this time it's going to reject it. Yay! See, now the protected branch hook declined the thing, so I need to open a pull request. Whew. We're back. So now we are going to continue the setup. And to set up the GitHub action, we need to go to another repository, which is ggshield-action. And this explains that we need to create a workflow. So GitHub actions are defined using YAML files like this one.
So this is very similar to the YAML file you set up for the pre-commit and pre-push hooks. Well, I mean, it's different, but you're describing what you're wanting to do with your detection.
Yes. GitHub let us create those things directly online. So that's what I'm going to do. Configure a new workflow. Create CI. CI is a good one. And I'm going to copy past this and replace the whole thing here. Boom. So we can see that it's going to run on push and on pull requests, but it's a bit limited on push because it can't fail the push. So that's why the pull request is really important. And one important thing to notice is this part, which specifies the API key to use. Just like before, we had to authenticate using ggshield auth login. We need something similar here, but we still use the old version of creating an API key. And obviously, you don't want to copy paste it here because you would leak your GitGuardian API key, and that's no good.
So we need to add the API key somewhere else so that GitHub knows it's there, but we're not exposing it in our repository.
Right. And we are going to do this from the settings. And of course, I need to create a new branch because now I can't commit on master. And so, yes, create CI.yaml as good as it can be. What new file? And I have a pull request here. The thing is, right now I think it's not going to run. Let's see, because the CI.yaml has to be inside the main branch to take effect. Okay, so well, I can't commit because I insisted that also administrators needs to requires approval. So let's relax things a bit just because it's demo. Sorry, it's a little bit cumbersome, but we'll see. And now, well, I have this special thing to merge. Right. Okay. Yay. So now, if I look at my code here, I can see that it created a .github workflows and a CI YAML, but I need to set this key. So I need to go to my dashboard to do this, but it's I'm going to.
I'll remove you. I'll remove you from the screen to do that.
Okay.
So you go ahead. Your screen's gone. So you won't be leaking any secrets.
Good. That's good.
But as we said at the start,
actually,
you continue. Sorry.
Yeah. Let me tell you when you can put me back and it's not dangerous for anyone. Let's see. I think we're good here. Can you put me back just a second? So I just reduced the thing so you can't see too much, but basically here I'm logged on my dashboard and I clicked on API and then on the new personal access token. So this is the old way of authorizing ggshield. So I add the scan option, which is required for ggshield. I'm going to say that this is for my CI. create token. Can you remove me again?
Sure thing.
Yep. Here we go. And my token is displayed here. So I'm going to copy it to the clipboard and go back here. Yeah. Can you bring me back?
You're back.
Okay. Yeah, I'm back. And I will ask you one more time. But so if I go to secret actions, here are where I can define the secrets that is referenced in the YAML file. So you can go new secret, and here I enter GitGuardian API key. As you remember, this is the name we found here.
Mm-hmm.
And now I will ask you to hide me again so that I can
no
pass
problem.
my key. Add secrets. And yes, you can bring me back. Sorry, it's a
There
bit
we are.
tedious. So as you can see now, we have a repository secret added here. And we can try to file a pull request and see if it catches our problem. So here I created a commit on master, but that didn't work because it was not allowed. Oh, let me, sorry, just going to bring back the branch protection so that we play by the rules. There we go. Okay, so now what I'm going to do is create another branch and say, okay, so I can't commit in master. I'm going to create a branch named add config. And since it started from master, it already contains my bad commit, the secret one. And I'm going to push this one. So if I push
you're pushing a secret
dash,
to the remote server now.
yes, using the new branch. And okay, my new branch has been pushed. So at this point, the secret is already public, so you would have to remediate it. And GitHub helpfully tells me in the remote messages that I can create a pull request for this new branch by clicking here. So this is what I'm going to do. Yes, I'm going to add a secret. Create pull requests. And hopefully, if everything goes well, we are going to see SCI, but it's not really happening. Why is that, you ask? I don't know. Oh, actually, things have happened already here. Interesting. We have 2 workflow rounds here. So why is it not there? Let's see, maybe I made some stupid mistake. Well, we can already look at this one. It scanned, it found nothing. So this is more than good. Maybe this thing is having a hiccup. Let me check what we did again. Oh, that looks all good.
Live demos.
Yay!
Is it an issue with the branch protection, or is it the CI is not running? Is that what's happening?
Really, I have no idea what happened here, but something is wrong, and I think maybe we can trigger it from here. No, stupid thing. New request. Come on. No, doesn't want. No, I would have to investigate why it didn't
Can we
include
make
it.
the action run without the branch protection? Like a commit with a secret in it, just to see the action blocking, just to see how the action displays.
Let's see. Well, the thing is, I can't trigger it again from here, but I could make it. I can make it possible to trigger it manually. Oh, I wonder if this name would be wrong. Hold on, can you hide my screen just a second?
Yeah, sure. I'll go in and while you're figuring on that, I'm going to answer. We're going to go look at some questions that we have here.
Okay.
So, how do you enforce developers to run on the CI on the client side? This is actually an interesting question that we get a lot, and the problem is that you can't. And this is the problem with client-side secrets detection. So, client-side secrets detection can be bypassed, pretty much, at always. You can enforce at a pre-receive on the server, but you can't really enforce that your developers do that. And even if you install the pre-commit hooks on all developers' machines, that becomes the policy when you roll out a laptop. You can bypass pre-commit hooks very easily by just adding -n at the end of your commit. So this is the problem of why we fundamentally need remote server detection, but client-side detection is fantastic because we prevent it, but we can't rely on it. So hopefully that answers that question. Since it requires a connection to GitGuardian, what type of data is transferred to GitGuardian server, or are we only pulling the logic down? So ggshield used to be completely stateless. It's not. We don't store the secret. So if a secret is detected, that secret is not stored anywhere on GitGuardian from the API. What is stored, though, is the type of secret that it detected. And the reason why this is that if you're managing a team and you're wanting to look at the secrets that you're finding, so you have your GitGuardian dashboard set up, you can see how many secrets are being stopped on the client side, what secrets they are, but you can't see the secrets themselves. So there is some data stored there. We're not completely stateless on that API at the moment. So hopefully, Brett, that answers your question there. As we go through, can you specify which of the features are in the on-prem version versus the public version we are using today? So I'm assuming you're talking about GitGuardian. So everything today, there's no features of GitGuardian that are just available on the on-prem version. If you have on-prem GitGuardian, then the advantage is that you controlling ggshield as well. That's also installed on-prem, but there's no features that we're missing. So for everyone that's asking, the session is also going to be recorded. And I have some other tutorials on our YouTube channel. So if you type in GitGuardian onto YouTube, you will see some tutorials on how to do what we've talked about, how to set up GitHub Actions. They actually need to be redone because we've improved our authentication process. So as Orleans showed at the start, we actually no longer need to do that, go onto the dashboard and create an API key. We can do that. Can we use ggshield post-commit? Well, you can use ggshield with any data, but you can use it in a pre-receive area, or you can use it on your CI environments. But so you can use it in different places. But the problem is that those secrets are still exposed at that point. Are there any comparison studies done on ggshield and its competitors to see types of false positives and things? I don't think a comprehensive study has been done. We've talked about it, but it's always very challenging to know to be able to even get accurate measures on that, because one thing that we're very good at GitGuardian is removing false positives. But it can be difficult to create a comparison for that. But I'll definitely invite you to have a little bit of play yourself and see what happens. The problem with evaluating this is that GitGuardian, unlike other people, does do lots of cool things to improve our results. Now, these things include validating secrets. So if you leak an AWS key, we'll check that it's a valid AWS key. If it's not, or if it's not a valid Slack key, then we may not flag that. So if you're using sample data, it is always challenging because sometimes it will appear like we've missed something, but that's just because we've validated it and we've found out that that's actually not a real secret. It's not posing any threat. So it can be hard to do those comparisons too. Python is required for ggshield, Tom, for you asking. If you used ggshield in the past, what were the challenges, friction points you had to overcome? Let me know in the comments. Oh, that was from me. I should have looked at the name. Secret scanning in GitLab. Yes, you can. You can scan secrets in GitLab. So GitGuardian natively integrates with GitLab. But if you want to use ggshield, then you can also install that on the areas. I feel a lot of people don't think a secret is compromised when putting it in a private repo. How can you explain it to them that it's not actually the case? Well, there's been a lot of examples, a lot of use cases where source code has been involuntarily open sourced. So Twitch last year is an example, Samsung, NVIDIA, Microsoft, or this year from Lapsus. All of these companies have had their secrets exposed. Well, not their secrets, their source code exposed. And inside that is secrets. We've also seen in the code.cov supply chain breach, I can't explain that completely now, but where companies like HashiCorp, Rapid7 had their private source code accessed through a supply chain, through a third-party tool, code.cov. So that's really interesting because it kind of shows that people can access your private source code through different methods. And in addition to that, there's very few people that you want to have access to all your secrets. And probably no one should have access to all your secrets, right? But everyone has access to your source code, even your interns, your developers, your product managers. All of them have access to your private source code. So when you're looking about, okay, are our secrets exposed? Well, you have no control over who has them. The source code is going to be cloned into multiple different areas, and basically you've lost complete control. If a secret ends out somewhere where it shouldn't, you have no idea about it. So that's why private repos are not safe to store secrets. So please don't. Well, nearly everyone does. Large companies still use that, but sure. What would be the best way to report outdated documentation to the team? Or you can report to me. I think Olion's done too. I can see him, so I'm gonna bring him back. But support@gitguardian.com is an email address, or you can probably raise an issue on GitHub. We'll try and rectify that as soon as we can, if we can. Okay, Olion, are we ready? Can I bring your screen back? Okay.
Yes, you can. So what was missing is this one: require status check to pass before merging. So once I check this, then the pull request run the check, and thankfully it failed. And if we look at the details, we can see the same output here with the secret we found. So now we are happy that the secret was found, and we can, as I said, it's been leaked now, so we have to remediate it. I'm just going to do this and assume that we are going to import some code here and read it from the environment. Let's make this a bit real. But I don't check it, so maybe it's full of people. Right. Oh, this is better.
So we're removing the secrets from hard-coded, adding them as environment variables, which they should be. So now there's no secrets in that.
Yes, and I don't want to just commit and create a new commit. I need to rewrite the other one. So that's why I'm going to use git commit -- amend to commit the new one, to create a single commit with the both changes. Add config. And if I look at the history now, I see that I'm doing something nicer. And then if I can't push, because obviously the branch on the other side is not the same, so I have to push false. That's what happens when you rewrite history after it's been published.
You're forcing the remote version to match your local version. That's what you're doing now.
Yes. So and
I can see that the check run started.
Yes, but actually, what's important to know is that even if you do this, you're not fully safe, and you would need to rotate the secret anyway, because at one point the secret was on the internet here, and you can actually pull it if you still know the SHA for the secret itself. You can ask GitHub to remove them, but it's still too late. Okay, let's see. This gets started. Maybe it was just slow. Anyway.
Well, I think we can get into some questions now.
Yes.
A bit more because we're running out of time. But don't fear if you've missed any of this. There are videos. This will be on YouTube, and there are tutorials on how to do this, plus other things like scanning Docker images with ggshield. So for sure. We have some questions in there. How do we scan Docker secrets using ggshield? So I probably don't have time to show you, but how do we do that? Is it possible?
Oh, actually, I can show it. It's quite fast if you just bring me back. So ggshield secret scan. If you can see here, there are lots of things, and I can say, okay, I'm going to scan the latest. Let's assume that I take an image I have locally, otherwise it's going to be slow. Bam! Oops! Sorry. So this is how you would do it if you were not using my Debo user, who is not allowed to run Docker.
Right.
Okay.
But
that's basically
it. Secret scan Docker and then the Docker image, and that will scan it. And you can pull so that, and if you can you scan them from Docker Hub, for example? Can you pull it down, scan it in one command?
Yes, that's what the command does. Actually, let me switch to a user with more power. Okay.
Right, and now we're scanning the Docker image. Oh, that's great.
Oh,
thanks for invalidate the key. We don't have the key there. Oh, that's all right. We weren't prepared for that one. So. Yeah. We had some questions here from Manuel. What is the best practices to share secrets with the team? How do you share actual secrets with your team?
Okay, so there are different approaches here. One of them is to get them from the environment, but then that doesn't really answer how do you put them in the environment in the first place. And in GitGuardian, we use HashiCorp Vault to securely share secrets. And there are other tools like that. That's what I would recommend.
Yeah, this is actually a hotly debated topic too, because there really isn't any perfect answer, because Vault is a very heavy tool. You need to be quite mature to run it and manage it. But there are ways. Some people like to encrypt them and store them in Git. This is technically a very bad thing to do because the encrypted version still sprawls. So your secrets are encrypted, but the encrypted file you lose track of. I personally don't think that that's terribly bad if you're a small team, but there are different levels of maturity. Some people share them with secrets managers. Some people share them with password managers. I think it really depends on the situation. The best practice is Vault or a keyless or some specific management tool, but you need to look at what's going to work for you. And the reason why I don't always think that the best solution is the right solution is because you have to be willing to use it. If it's too complicated, you will bypass it and it becomes useless. So find something that actually works for you. Yes. Well, I think that we're actually gone over time. But thank you, Leon, for your time here. Super interesting. The replay will be on YouTube. As I said, there's some other videos on YouTube around ggshield as well, and we're going to be producing a lot more content. Now,
And yeah, just for the record, if you bring me back, you can see that the check has now passed.
Okay.
We are ready to merge.
We're ready to merge. It just took a little bit of time for GitHub to catch up. All right. So there was some prizes to be won. I know we're running out of time, so I'll just quickly see if there are some people. Here we are. So the people that have won Amazon gift card, Andre K, congratulations. And also Matt Rodriguez. So Andre K, Matt Rodriguez. I'll be contacting you. I'll send you out the Amazon gift card that you won. And look forward to seeing you guys at the next webinar. So please keep an eye out for that. And also, please let us know in the chat section there. Write us a little comment as to what you would like to see on other webinars, as there a topic you would like to cover. So please let us know. And also, the marketing team will kill me if I don't say this. There's a button down there that says star the ggshield repo. So, come on, give us a little star. Give us a star. It takes a minute, but yeah. So congratulations to everyone. Thank you, Orion. And we're a little bit over time, so I'll let everyone get back to their days. But thank you for tuning in, and I look forward to seeing you next time. Thanks, everyone.